Hi everyone. So this is another question or another example of what we call graph analysis. Okay, and graph analysis is when I present you with a graph. Usually the graph I'm giving you is f prime, and I ask you all sorts of questions about the function itself. Okay, I do see some people trying to draw what the original function would look like. I would recommend not doing that. First of all, it's a time burner. It's unnecessary. And secondly, sometimes you draw things in that aren't accurate and then assume that what you drew is correct. Okay? So we're going to do all of this just looking at the graph of f prime. What I usually do with these questions is make myself a key. Now, right now, that key is going to be pretty simple. But as the class goes on and we learn more and more things that we can do with these graph analysis questions, sometimes that key gets a little more complicated. So what I am looking at right now is f prime. So f prime of x is the graph itself. So if I ask you anything about f double prime, what I'm really asking you about is the slope of the values on this graph, right? Because that would be the derivative of this graph. So when I ask you questions like this, find f prime of 0. Well, f prime is just the graph itself, so I'm just reading values right off the graph. So for example, f prime of 0 would be, let's see, how is this graph numbered? So that'd be 1. Okay. F prime of -3 is just at -3, which is here. What is the function value, which looks like it's 2? Okay, really testing my vision here today. Now, these ones that are asking about f double prime, that's asking a slope question. And I can't always ask you for slope. Like, for example, I couldn't ask you for slope at like a random point on this curve because you would have to have an equation, you'd have to find a derivative, all of that. But there are some specific situations that I can ask you about the slope. So for example, f double prime of 0, I want the slope of the tangent line at this point. Well, since that's a minimum value, we know that our tangent line looks like this, right? And so the slope would be 0. F double prime of 2, that is going to be, let's see, right here. And since that is on a straight linear segment, this is the other time that I can ask you for a slope, I can find the slope of this segment, and that represents the slope at 2, right? So when you have just a straight line, that slope is constant, so I can find that. This is going down, let's see, 0.5 and over 1, or I could think of it as like going down. That's really just 1 unit, the way this graph is being numbered, right? Because this is, we're saying is 1 here, this is 2. So this is going down 1 and over 2 spaces. So that slope is a -1/2. Okay. Okay. This is another fun thing that they like to do with these types of expressions is then they make up a new function, right? They say g of x is 2 times f of x minus 3x. Now, we don't even have f of x in front of us, right? We only have f prime. But we can write equations for what g prime would look like. So g prime of x would be, now that 2 is just a constant multiple. So if I'm taking a derivative, this is just going to be 2 times f prime of x minus 3. And g double prime would be the derivative of that, which would be 2 times f double prime of x. And the minus 3 goes away because when I take a derivative, it's equal to 0. Okay, so now when I ask you for g prime of 0, I have my equation for g prime up here. So I'm going to say, well, that's 2 times f prime of 0 minus 3. Okay, f prime of 0, that's straight off my graph. We actually figured that out over here. That's 1. So this is 2 times 1 minus 3, which is -1. Okay, obviously I don't know that you would need to write out all of that work, but I wanted you to see what my brain was doing. G prime of -3 would be 2 times f prime of -3 minus 3. F prime of -3, I feel like we figured that out already, was 2. So this is 2 times 2 minus 3, which is 1. Okay, g double prime of 0. Well, that's just 2 times f double prime of 0. F double prime of 0 we said was 0. So that's still just 0. G double prime of negative 2 is 2 times f double prime of negative 2. Did we figure that out somewhere? Oh, that's negative 2. Oh, interesting one. I wonder if that's a typo. I wonder if I meant for that to be a 2. At negative 2, there is no derivative, right? We can't find the slope at that point because that's a place where the derivative does not exist, right? So f double prime at this point is a dne. So this is 2 times something that does not exist. That means that this would just also not exist. I thought for sure that was going to ask me about positive 2 because I already had that. But nope, for negative 2, we would say it doesn't exist. Okay, find the critical points for g of x. Okay, critical points, this is where you really have to think about like what you know about these functions. Critical points happen when the derivative equals 0, right? Okay, we want to be looking at the g function though. We want this derivative to equal 0. So what I want is when does 2 times f prime of x minus 3 equal 0? Okay, let's add the 3 to the other side. So I want 2 times f prime of x to equal 3. Keep going over here. Divide by 2. What I really want is when does f prime of x equal 3 over 2? That's where my critical points are going to be, right? Because I set my derivative of g equal to 0 and solved. So I want to look at this function because this is f prime up here. But now I'm not looking for when does it equal 2. I'm looking for when does it equal 3 over 2. All right, let's find that. 3 over 2 would be 1.5. So here's 1.5. That'd be this right here. Okay, and I'm looking for when do these things occur. This looks like it's at negative 1.5 because this would be negative 1. So negative 1.5. And my other one is this one here, which would be negative 3.5. So those would be your critical points. Oh, I'm so sorry that you couldn't see that. Those would be your critical points of the g function. Okay, those are the critical points of g. Not the critical points of f, but the critical points of g. Okay, do these points represent maxima or minima and justify? Okay, so really what we did here is say that this is the f of x function. So we know normally we would be looking at like, does this derivative change from positive to negative or whatever? For the g function, it's almost like this is our x-axis, right? So when we're talking about g, not f, this is a negative derivative, this is a positive derivative, right? This is below the new x-axis, above the new x-axis. This is positive, this is negative. So this is the negative 3.5 one. My derivative would be changing from negative to positive. So x equals negative 3.5 is a relative minimum. And negative 1.5 is, our derivative this time is going from plus to minus, is a relative maximum.